Ionic radii. Which radii? Ionic radii. Fourth number is ionic radii. Ionic radii. It is defined as the distance of the outermost orbit. The distance of the outermost orbit. The distance of the outermost orbit in an ion from the center. In an ion from the center of its nucleus is called ionic radius. Ionic radius R. The distance between nucleus of an ion. The distance between nucleus of an ion. The distance between nucleus of an ion and the point up to which the nucleus has influence on its electron cloud. The distance of the outermost orbit in an ion. The distance of the outermost orbit in an ion from the center of its nucleus is called ionic radius. And the distance between nucleus of an ion and the point up to which the nucleus has influence on its electron cloud. It is also expressed in angstrom. It is also expressed in angstrom. It is also expressed in angstrom. And R plus, R minus. This is an ion. This is an ion. This is an ion and this is cation. 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 R plus cation and R minus anion. And this is the distance D. R0. Ionic radius. R minus anion. Anionic and R plus cationic. It is also expressed in angstrom. Ionic radii is also expressed in angstrom since elements are neutral. Hence, they form cation by losing electrons and from anion. Hence, they form cation by losing electrons. and from anion by gaining electrons, and from anion by gaining electrons, due to which differences arises in their size. Differences arises in their size. This is the small and this is the big. So the differences arises in their size when an electron is removed from a neutral atom. When an electron is removed from a neutral atom, then it converts into cation. Then it converts into cation. The remaining electrons are comparatively more attracted by the nucleus, due to which ionic radii decreases. Hence, the size of cation is smaller than the atom. Cation is smaller than the atom. When an atom gains electrons, it is converted into an anion. Due to greater number of electrons, the attraction is lowered, due to which size increases. Hence, the size of an anion is larger than the corresponding atom. In ionic solid, the distance between the center of neighboring ion is known as internuclear distance R0. Internuclear distance R0. Hence, ion is known as the distance between the center of the distance between the center of neighboring ions is known as internuclear distance. Internuclear distance R0. Internuclear distance R0. Then R0 equal to R plus R minus, and that means R cation plus R anion. When one or more electrons are removed from an atom, is called formed. Capital M is dash to M plus N plus Ne, metal, which is metal. M is metal. Example: atomic radii and ionic radii. Atomic radii of sodium equal to 1.57 angstrom and Na plus. Ionic radii of sodium 0.98 angstrom. Ferrous. Atomic radius of ferrous 1.17 angstrom and ferrous Fe2 plus equal to 0.76 angstrom and Fe3 plus equal to 0.64 angstrom. Ionic radii of ferrous and atomic radii 1.17 angstrom. When an atom gains one more electrons, an ion is formed. When an atom gains one more electrons, an ion is formed. Anion is formed. Then the X plus Ne, arrow mark of X minus N, non-metal. This is the non-metal. This is the non-metal. X is the non-metal. As an example, we take oxygen, O plus 2E, arrow mark of O minus 2. This is the atomic radii and ionic radii. Atomic radii and ionic radii. Atomic radii of oxygen equal to 0.60 angstrom, ionic radii O minus 2 equal to 1.40 angstrom. Phosphorus 0.72 angstrom and F minus 1.36 angstrom and chlorine equal to 0.99 angstrom and chlorine minus negative chlorine equal to have ionic radii equal to 1.81 angstrom. As I show example period variation. Which variation? Period variation. Period variation. Period variation. The variation of ionic radii follow the same trend as in atomic radii. As in atomic radii, ionic radii increases from top to bottom in a group. Ionic radii follows the same trend as in atomic radii. Ionic radii follows same trend. Follows the same trend as in atomic radii. As in atomic radii, ionic radii increases from top to bottom in group. Ionic radii increases from top to bottom in a group. Ionic radii decreases from left to right in a period. From left to right in a period. Exception. But in case of transition elements, the variation is small due to D block contraction. Second number, the variation in ionic radius of M3 plus from metals, from La3 plus to Lu plus 3 is small, approximately constant due to lanthanide contraction. Due to lanthanide contraction. third number is the ionic radius of second and third is nearly same. The ionic radius of second, the ionic radius of second and third is nearly same. Same due to lengthened contraction. Due to lengthened contraction. Due to lengthened contraction. Thus zirconium plus 3 1.45 angstrom and hafnium plus 3 1.44 angstrom have nearly same ionic radius. Same ionic radius. Radius of isoelectronic species.